Assalamu alaikum everyone. Welcome to Mathematics with Shahab Yaqub. We are on the third lecture of sequences, number pattern, and this is lecture number 26 of Algebra. So let's work out some more past paper questions. Let's look at this question, which is question number 65. So let me underline this thing and let me read this part. It says the first term of a sequence is 13. The following terms are found by alternately adding 4 and 6 to the previous term. The first 6 terms are given over here. Now, what are the first 6 terms? Look at it very carefully. There is 13, then there is 17. So let me just mark it alternately. So this is 13, this is 17, and then there is 23, and there is 27, and then there is 33, and there is 37. Now, before I read further, I think it is very clear that the red ones are connected and the blue ones are connected. So there are two series. There is a difference of 4, there is a difference of 6. That means we cannot consider the whole thing as one series. So the red one is one series. So let me mark this down. That is T1 and T3 and T5. That is one series. That is an AP. So T1 and T5 and T7, that is an arithmetic progression. And I can say the first term is 13 and the common difference is 10. So we can consider this thing as one thing over here. Now let me focus on the blue one. That is T2 and T4 and then T6. So therefore, I can say T2, T4, T6. This is another AP in which the first term is the second term, which is 17, and the common difference is 10. So now if your vision is clear, you will have no problem in solving the parts that are over here. The first one is write down the next two terms, 13, 17, 23, 27, 33, 37. That means the next two terms, the first one will be in red, and let me write it over here, and the second one will be in blue. So this one will be what? So 33 will become 43 and 37 will become 47. So this is basically T7 and T8, that is right over here. So that is the answer for this particular part. I hope it's all got all clear. Now it says write down the value of the term that is closest to 999. Now, if I look at it closely, the last digits are 3737, and this keeps on going. That means if we are talking about the two terms that are closest to 999 for part B, so for part B, let me write the two terms would be 993 and 997. These are the two terms that are closest to this. Now it says write down the difference between the values of the 91st and 93rd term. Now we have to develop a pattern. What is that pattern? So I have this pattern, which is T1, T5. Actually, this is T1, T3, T5. So let me just clear my working. That was just a small slip of pen. So this is T1, T3, and T5. So we have T1, T3, and T5 versus we have T2, T4, T6, T2, T4, and T6. So this is like an odd number series. If I look at the subscript, this is like odd numbers. If I look at this subscript, this is like even numbers. So 91st and 93rd, that would fall into this category. So T91 will be there, and then T93 would be there, and T95 would be there, and so on. So the difference between any two consecutive terms between T1 and T3 is what? That is 10. So between 91 and 93, the difference comes out to be 10. All good, all clear? Now it says find the 80th term. Now, the 80th term of the series will be built upon this blue one. So the 80th term of the series, part D. So first of all, the answer of part B is over here. And then part C is right over here. And let me focus on part D. So if I am looking at the 80th term, so that is the even numbered terms. So therefore, they are which ones? They are T2, T4, T6, dot, 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 all the way till 80. So now if I think about it, out of these, this is like the first term, this is like the second term, this is like the third term, and T80 is actually like the 40th term for the blue numbered series. Are you getting it? This is 1, 2, 3, 4, 5, 6, 7, 8. But if I just focus on the blue one, the second is actually the first one, the fourth is the second one, the sixth is the third one, the eighth is the fourth one. Therefore, the 80th blue term, so let me just use color over here. The 80th blue term is basically T40. Now, the first term is 17. The common difference is 10. So we have the first term is 17. Common difference between two terms is 10. And we are looking for n is equals to 40. So therefore, T40, which is the 80th term, that is a plus n minus 1 into d. A is 17, n minus 1 is 40 minus 1 into d, which is 10. So this is 17 and this is 39 into 10. That is 390 plus 17. So 17 plus 390, that comes out to be 407. That is the answer for this part. So part D is done. So part D, 407, and the other terms are right over here. And this one, the two terms that are closest to 999. So this one is the closest. I forgot to underline it. That thing is done. Now it says the nth term is 203. So let me copy this page. Copy this image. Let me add a page, which I already did. And now let me focus on it again. So that is the blue, the blue, the blue. And this is the red one, the red one, the red one. So now over here, this is T1, T2, T3, T4, T5, T6, and so on. And it says the nth term is 203. The last digit is 3. That means now we are focusing on the odd numbered term. So I have T1, I have T3, I have T5, dot, dot, dot. And this is like 13 and 23 and 33 all the way till 203. So now remember this thing, that if this is the first term, the common difference is how much? 10. That is 13. The common difference is 10. So let me find how many terms are there till 203. So therefore, I'm looking for 203. So therefore, Tn, that is 203 is A plus n minus 1, which is n minus 1. N is what we are looking for into D. So 203 minus 13 is n minus 1 into 10. Therefore, 203 minus 13 is 190, is n minus 1 into 10. Therefore, 19 is n minus 1 after division by 10. Therefore, n comes out to be 20. That means there are 20 terms in the series. So either I can write it down like this one, T1, T3, T1, T3, T5, T7, and T9. And then we have to go for 20. So, and then it's T11, and then 13, and then how much? 15, then 17, then 19. And then T, how much? 21st, and then T 31st. Are you getting it? 11, 13, 15, 17, 19, 21, 23, 25, 27, 29. And this is 31, 33, 35, 37, 39. So 339, that is the 20th term of the series. So what are they asking for? Find n. So therefore, n comes out to be 39. That is how you get it. So this, I wrote it out. So write it out. That is what I have done because there are 20 terms in the series. Of course, I can also do a bit of calculation. So let me write it alternatively. We have 1, 3, 5, all the way till how much? There are 20 terms. So this is 1, 3, 5, and we are looking for this. So A is 1, D is 2, N is 20. So let me write it down. Tn is A plus N minus 1 into D. Therefore, this is 1, this is N minus 1, 20 minus 1 into D, which is 2. This is 1 plus 19 into 2. 38 plus 1, that is 39. That means the numbering is T39 because it's not like 1, 2, 3. It's 1, 3, 5, 7 because it was an odd numbered series. So I hope it's all good, all clear. And let me show you the answer. I think the answer is right over here. That is this. So the value of N is T39. So that was a good question that was supposed to be done. Now, let's look at this number pattern. Just have a look at this one. And why don't you get started with this? Just write down the first answer. The first answer, the recording is already on. And it's a very simple pattern that you can look for. Okay, Ji. So let me focus on this. It says that a pattern of numbers is given below. There is row 1. So let me focus on it like this. Row 1, there is a 1 over here. Row 2, there is a 2 over here. Row 3, there is a 3 over here. And hold for a second, row 3 is there. Row 4, there is a 4 over here. And then the next number is 1 more than that. So 1 becomes 2, 2 becomes 3, 3 becomes 4, 4 becomes 5. And then whatever the two numbers are multiplying downstairs, that is like a fraction over here, 1 over something. So therefore, 1 over 1 is there, 1 over 2 is there, 1 over 3, 1 over 4. Similarly, this is 2 and then 3 and then 4 and then 5. So it's a very simple pattern that you can see. There is nothing special in this one. Write down row number 10. So I'll write it like this. This is row number 10. And I'll write 1 over, this is 10 into 11, which is 1 over 10 minus 1 over 11. And let me use the same colors as I did over here. So this is 11, and then the red one, this is 10, and this is 10. So that is how this answer is obtained. Now let's focus on this. Adding the first two rows gives the result. So now we have this thing. Let me again use the same color. This is 1, and this is 2, and this is 2, and this is 3. So this comes out to be this. Why? Because there is a step that is missing over here. Let me write this thing. This is 1 over, let me just go back, 1 over 1 minus 1 over 2. That's the first one. And this is plus 1 over 2. And this is 1 over 1 minus 1 over 2, 1 over 2 minus 1 over 3, 1 over 2 minus 1 over 3. Okay. Now again the same colors. This is blue, this is blue, this is red, this is red. That's how this is broken. So basically this one is over here, this one is over here. This has a negative sign, this has a positive sign. Because of this, this cancels out. What are we left with? 1 over 1 minus 1 over 3. So basically we are picking this thing up. We are picking this thing up. And this is 1 over 1 minus 1 over 3, which is 2/3. This is the result of the first two rows. So the second row, this is second row that goes up. This is 2 plus 1 that goes down. So if I focus on 2 rows, for 3 rows, that is the third one, and that is 3 plus 1. So this is third, this is 3 plus 1. So very simple pattern. Write down the result of adding the first 4 rows. So I'll simply write this thing down. Adding the first 4 rows, what will it be? So this is 1 over 1 minus 1 over 3. So in 2, this is 3. In 3, this is 4. In 4, this is 1/5. This comes out to be 4/5, which makes perfect sense because the 4 is at the top and 4 plus 1 is at the bottom. Now it says use the pattern to write down the value of this thing. So now this is what? This is the first row. This is the second row. This is the third row. This is first, and then second, and then third, and this is 19th row. So if this is the 19th row, it should be 1 over 1 minus 1 over this thing. This for 4, this is 5. For 19, so this is 19 rows. So this is 1 over 20. That comes out to be 19 over 20. You can also write it directly. This is the 19th row number and 1 added to it. So let me do this one. An expression in terms of n for the result of adding the first n rows. So this should be n over n plus 1. That is the rule. 19th row, 19 over 19 plus 1. First 2 rows, 2 over 2 plus 1. So let me just use this thing. So this is 2 over, the numerator is 2, and this is 2 plus 1. For 3 rows, this is 3 over 3 plus 1. For 4 rows, 4 over 4 plus 1. For 19 rows, 19 over 19 plus 1. For n rows, n over n plus 1. That means I can even answer part B. That is 109 over 110. So 110 is basically 109 plus 1, and this is 109. So the number of rows that adds up to this, 109 rows that adds up to this. So sometimes in maths, you can get something from here, go to part C, then go back to part B. So that is perfectly good, perfectly all right. So that was another nice question that we obtained. And these are the answers: 4 over 5, 19 over 20, 109, n over n plus 1, and this is all good. Okay, so now another diagrammatic type of representation, and this is the same thing that we have done before. So let me just do this one. So we have a pattern. A sequence of pattern is made up of using dots and lines. So pattern P, the first pattern, number of dots, 1, 2, 3, 4, 5, 6, that is 6. Second pattern, that is 11. Third pattern, that is 16, and so on. So I think this is pretty basic. 6 plus 5 is 11. 11 plus 5 is 16. 16 plus 5 will be 21. Complete the table for pattern 4. That is done. Find a formula for the number of dots in pattern P. So this is an arithmetic progression, nothing special, very simple thing. A is 6, common difference is 5. This is an AP, you have to realize, because the difference is constant. Tn is A plus n minus 1 into D. Tn is A is 6, n minus 1 is n minus 1, D is 5. This is 6 plus 5, n minus 5. This comes out to be 5n plus 1, that is Tn, and that is the answer for this particular part. That is 5p plus 1 instead of n. Another question of the same type. Let me skip this. Another question is also like this. And let me just pause the recording. Hold for a second. I would like you people to try this question out. So let me just pause it. So now let's look at this question. It says the diagram below shows the first 3 patterns in the sequence. Pattern 1, there are dots like this. Pattern 2, pattern 3, and it's just about the dots. So it's not about the shape as such. 1, 2, 3, 4, 5. Now in 3, how many dots are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 dots. Let me write over here. So 5 plus 3 is equals to 8. 8 plus 3 is equals to 11. 11 plus 3 will be 14. 14 plus 3 would be 17. So it's an arithmetic progression because the difference is constant. That is what we have studied in the very first class. Part B, find an expression for the number of dots in pattern n. So that means they're asking for the nth term. The term formula, Tn is a plus n minus 1 into d. What is a? A is the first term. So a is 5. What is d? The common difference, the constant difference. That is the second minus the first term. This is 5. This is 3n. First of all, let me write this thing as n minus 1 and d is 3. Now expand it. This is 5 plus 3n minus 3. This is 3n plus 2. That is tn. Last one. In the sequence pattern, P has 83 dots. Find the value of P. So if I write pattern P, that would be 3P plus 2. And how many dots are there? 83. So 3P plus 2 is equals to 83. 3P is equals to 81. Therefore, P is 81 over 3. That comes out to be 27. So basically, we are looking for the nth term, the 27th term. So the 27th term will have 83 dots. As simple as this. So 27 term, 3n plus 2, 11, 14, and 17. That is the answer. Now, some questions that I'm leaving at blank, that is basically for you to try out. And I think this is a nice question. So let me go over this question. So over here, let me highlight this thing. And it says there is pattern 1. There is a cross over here. So let me just focus on this. So there is one cross, and then there are crosses, and there are circles. So let me focus on the crosses with this red pen, and then you can see it very clearly. Let me just remove this color from here so that there is no confusion. So these are the red crosses, and these are the blue circles. Okay, now let's get started with the red crosses. So the crosses are 1, 3, 6, and 10. And the blue circles, they are 0, 1, 3, and 6. So let's say what is the pattern over here for this and for this one. So first of all, this is the cross, and this is the circle. So 1, 3, 6, and 10, the pattern is given. There is a difference of 2, and then there is a difference of 3, and then there is a difference of 4, and then there should be a difference of 5, and the difference of 6. That is the pattern. So 10 plus 5, 15. 15 plus 6 is 21. What about the blue one? 0 to 1. There is a difference of 1, and there is a difference of 2. There is a difference of 3. There is a difference of 4. So there should be a difference of 5. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. And what about the numbers that are over here? The total number. The total number. So let me just highlight this. So the total number, that is blue, and this is 1, 4, 9, 16, 25, 36. These are what? This we have studied before. These are square numbers. So these are square numbers. And this is basically 1 square, and this is 2 square, this is 3 square, this is 4 square, this is 5 square, and this is 6 square. Complete the table. That's already done. And let me just double check the values: 15, 21, 10, and 15. So this is 15, 21. That is for the red one, the 15 and 21. And this is 10 and 15. And then the next one that is already done. Find an expression in terms of n for the total number of crosses and circles in pattern n. So these are square numbers. So this is basically n squared. So the total is n squared, and the answer is right over here. Now it says an expression in terms of n for the number of crosses is already given. For the number of crosses, that is the red thing, that is already given. So this is n squared, and this is n. Half n squared plus half n. How many crosses are there in pattern 30? So this is pretty basic. So basically we have Tn is half bracket n plus 1. What I have done is that I have taken common. N square plus n, that is n plus 1, and half is taken common. So therefore, when n is 30, T30, that is half into 30 bracket 30 plus 1. So this is half into 30, which is 15, and n plus 1 is 31. So 15 into 30 is 450 plus 15. This is 465. I have done it mentally. I think it's a paper 2 question. So even though it's a paper 2 question, this part I've done it mentally, and that is 465. That is also good. Show that the number of circles is this much. So now I'm interested in the number of circles. In pattern is this thing. Now we have the green pattern. That is the total. That is a square number, which is n square. We have the crosses. So this is the cross that's over here. So now I'm interested in this thing. So I can say for part E, the total is the term for the red plus the term for the blue. The red is the cross, the blue is the circle. So this is n square. The term for red is half n square plus half n. So I'm using the expanded form because I have to do some subtraction. This is the one. And this is the blue one, the circle one. So take it to the other side. So therefore, n square minus half n square, which is half n square minus half n. That is the blue one. That is the circle one. And that is the answer. So quite easily done. This is proven. Okay. All good, all clear. Now, the number of crosses in pattern M is equal to 5m. Find M. Now, we have this formula for the circle. So part F, Tn is half n square minus half n. It says the number of crosses is equal to 5m. So Tm equals to 5m. So replace this thing, this n, this n, this n with m. So Tm is half m square minus half m equals to 5m. So this is half. Let me just multiply with 2. So this is m square minus m is equals to 10m. M squared minus m minus 10m equals to 0. M squared minus 11m equals to 0. M common, m minus 11 equals to 0. Therefore, m is 0, which is, of course, not possible. How can you have a series with 0 term? Or m is equals to 11, and that is the only answer that we get. So that is the basic thing that we are doing. It says the number of crosses. My bad. I think I made it for the circle. So it's for the total number. The number of crosses is the red one. That is half n square plus half n. So let me just do a correction over here. So this is not the red color one. This is the red color one rather than the blue color one. So my bad. And let me just clear it out. So therefore, this is half n square plus this thing. This is n, this is n, this is n, this is m, this is m, a plus sign over here. And let me just do this basic subtraction over here. And we got it all mixed up. So this happens, and this is in red color because we are talking about this thing. So I mixed up the crosses and this thing. So now let's multiply with 2. So this is m square plus m is equals to 10m. And m square plus m minus 10m equals to 0. Therefore, m square minus 9m equals to 0. M common, m minus 9 equals to 0. Therefore, m is 0, not possible. How can you have a series with 0 terms? And m minus 9 equals to 0. Therefore, m is equals to 9. And that is the only answer. So therefore, m is equals to 9. That is the only answer. So now this question is all done and dusted. Okay. Another question of the same type. Now, this looks like a nice question. Let me pause the recording. Let me minimize it so that you people can try this out. So now let's look at this particular question. It says the sequence of diagrams shows patterns made from some black beads and some white beads. Each diagram has 2 rows more than the previous. So first, let's look at this. This is 1, 2, 3, 4, 5. 5 rows. This is 1, 2, 3, 4, 5, 6, and 7. So there are 2 rows more and 2 rows more and so on. And then you can see the black beads and the white beads. So diagram number, there is there. That is basically 1 and 2 and 3 and 4 and 5. That's a diagram number. Total number of beads. That is 9, 16, 25, 36, and something else. Number of white beads. That is 7, 10, 13, 16, and something over here. And last but not the least, the green thing, that is the number of black beads, 2, 6, 12, and 20. Now it says, write down an expression in terms of n for the number of white beads. Now, first of all, if I talk about this blue thing, that is the white beads I have labeled in blue in diagram n. So you have to realize that this is about arithmetic progression. How do I know that? 7 plus 3, that is 10. 10 plus 3 is 13. 13 plus 3 is 16. 16 plus 3 is 19. So let me write over here 19. And I'll say the first term is 7. The common difference is 3. Therefore, Tn is a plus n minus 1 into d. That is 7 plus n minus 1 into 3. That is 7 plus 3n minus 3. That is 3n plus 4. That is the answer for the first part. As far as completing the diagram is concerned, I should have done that first. So this is 3 square. 9 is 3 square. 16 is 4 square. 25 is 5 square. 36 is 6 square. And this should be 7 square, which is 49. Now, if they're asking for the total number of beads, the red thing, that is right over here, the total number of beads. And if I talk about this diagram, that is square number. So for the first one, this is 3 square. For second, it's plus 2 square. 3 plus 2 is 5. 4 plus 2 is 6. 5 plus 2 is 7. For the diagram n, this should be n plus 2 whole square. So that is pretty basic. So Tn is n plus 2 whole square. And this is by sheer observation. And then if I talk about the black beads, what should I do? Find an expression in terms of n for the number of black beads, which is the black beads, that is the green color one. So the number of black beads, the green color one, that can be done by subtraction. So you don't have to think about it again. So basically, the white beads plus the black beads, that should equal to the total. So white beads, it's right over here, the blue color, 3n plus 4. This is 3n plus 4. The black bead terms, that is what you're looking for. The total is n plus 2 whole square. Give your answer in its simplest form. So TB, that is n plus 2 whole square minus 3n plus 4. Simplify it further. That is n square plus 4n plus 4 minus 3n plus 4. And then this is n square, 4n minus 3n, that is n, and 4 minus 4, that cancels out. So this is n square plus n, which is can be written as n plus 1. So TB is n plus 1. Let's double check. If I plug in 1 over here, so this is 1, 1 plus 1, which is 2. If I plug in 2 over here, this is 2, 2 plus 1, 2 into 3 is 6, and this perfectly works. And let's double check the answer. That is right over here, and that completes lecture number 3 of sequences. And also, this is Algebra 26, and that is the end of today's class. Stay tuned for more content.